In 1912, she wasn't just a ship. She was the largest moving object ever built by human hands. To beat the blistering speed of the rival Cunard line, White Star chose something else: sheer size and luxury.
It began at a dinner party. Lord Pirrie and Bruce Ismay sketched a dream of three giants on a simple napkin.
Belfast's Harland and Wolff shipyard transformed. 15,000 men were mobilized for the task.
They built the Arroll Gantry, a massive steel spiderweb designed to cradle the growing hulls.
On slipway number 3, surveyors marked the footprint. The beast's dimensions were finally set in stone.
Massive oak keel blocks were laid, the humble wooden foundation for 50,000 tons of steel. Then came the first steel keel plate, the literal spine of the Titanic.
Hydraulic machines squeezed white-hot rivets, fusing the flat keel plates into a single unit. A 5-foot vertical girder was erected, creating a rigid backbone to prevent the hull from sagging. Safety was paramount. A cellular double bottom was designed to keep her afloat if she ran aground.
African-American female workers installed transverse plates, creating a honeycomb of steel for immense structural strength.
Thousands of rivets ensured this hidden layer of the ship remained watertight.
The tank top was plated over, forming the eventual floor for the massive engine and boiler rooms.
To build the ribs, long steel beams were fed into roaring furnaces until they glowed orange. On the bending slab, teams wrestled the red-hot steel into precise curves before it cooled.
Once cool, these massive curved frames were transported to the slipway for assembly. High above, the Arroll gantry cranes hoisted the ribs into vertical position.
Frame by frame, the Titanic's iconic shape began to rise from the slipway.
The massive cast steel stern frame arrived, anchoring the ship's rear structure.
This massive casting was riveted securely to the keel, creating the mount for the rudder.
At the front, the bow stem rose, defining the ship's iconic cutting edge.
Horizontal deck beams locked the vertical frames together, creating a rigid cage. The skeleton stood complete, a cathedral of steel, ready. Thousands of steel plates arrived by rail from mills in Scotland. Machines punched holes for the 3 million rivets required to hold her together. Cranes hoisted the massive shell plates, some weighing over 4 tons, up the hull.
Plates were hung in an overlapping clinker style for maximum structural strength.
The riveting gang began with the heater boy, pumping the forge until the rivet glowed white-hot. He tossed the burning steel projectile through the air with practiced precision.
The catcher snatched the lethal bolt safely in a tin can. One slip meant disaster.
Inside, the holder-up braced the rivet against the steel plates with his entire body weight.
Outside, bashers hammered the soft metal head flat before it could cool and harden.
As the steel cooled, it shrank, pulling the plates incredibly tight against the sea.
For the thickest plates, huge hydraulic machines called Iron Men applied crushing pressure.
Finally, workers caulked every seam, hammering the edges to ensure a watertight seal. 15 massive bulkheads were installed, dividing the ship into watertight compartments.
Heavy vertical doors were fitted, designed to seal these bulkheads instantly in an emergency.
Engineers tested the gravity drop mechanism, critical for the ship's unsinkable reputation.
Thousands of steel pillars were riveted in place to support the weight of the decks above. Layer by layer, the distinct levels of the massive ocean liner took shape.
The heart of the ship began in the boiler shop, rolling thick steel plates into cylinders. Precision drilling ensured these high-pressure vessels wouldn't burst at sea.
Hydraulic machines crushed rivets to seal the massive double-ended boilers tight.
Corrugated furnaces were inserted, designed to withstand the hellish heat of the coal fires.
Finished, each boiler was the size of a house and weighed nearly 100 tons. Transporting these giants to the slipway required immense power and coordination.
Hold it right there! Now lower it easy! Watch the clearance on frame 72!
Deep below, workers secured the power plant that would drive the ship's propellers. Molten iron was cast to form the cylinders of the largest reciprocating engines ever built.
Lathes machined the crankshafts, ensuring smooth rotation for the massive pistons.
We're seeing a pressure drop on the third manifold.
Okay, I'm heading up to check the seals now.
The shear scale was staggering. Men looked like ants atop the cylinder heads.
Too large to move whole, the engines were disassembled for transport to the hull.
Watch the alignment here. Easy now.
Got it.
Secure the lower bolts first.
A Parsons turbine was built to drive the central propeller using recycled steam.
The casing was lowered, sealing the turbine that gave the Titanic her extra speed. Massive pipes connected the boilers to the engines, completing the steam circuit.
3 massive steel shafts were inserted to drive the ship's propulsion system.
The 2 outer propellers, cast in bronze, weighed 38 tons each. The center screw was smaller, designed to be driven by the turbine engine.
According to the blueprint, the starboard side needs adjustment.
Yes, the hinge alignment is critical here.
Above, the steel plates were coated in the line's signature deep black livery. To ensure a smooth slide, the slipway was greased with tons of tallow and soap. Brave teams knocked out the wooden keel blocks, transferring the ship's weight to the slide.
Now, the entire vessel rested solely on hydraulic triggers, ready for release. May 31st, 1911. Over 100,000 people gathered in Belfast to witness history.
There was no champagne. White Star Line tradition dictated a simple signal to launch.
Hydraulic valves opened. The triggers released the massive hull. Gravity took over. The 26,000-ton hull began to slide. In 62 seconds, the stern hit the River Lagan, displacing tons of water. Huge drag chains tore up the earth to break the ship's momentum. Tugs immediately secured the hull to guide it to the fitting-out wharf. The empty shell was docked. Now, the year-long fitting-out process began. The floating crane, Titan, arrived to lift heavy machinery aboard. Titan lifted the first of the 4 iconic funnels onto the deck.
Workers secured the smokestack to the boiler casing with heavy rivets.
A fourth funnel was added. It was fake, built purely for ventilation and aesthetics.
Watch the overlap on this section.
Going down another meter.
Masts were stepped and secured with heavy rigging to withstand North Atlantic gales.
Marconi wireless aerials were strung, the ship's vital voice across the ocean.
Welin davits were installed. They could handle many lifeboats, but few were carried.
16 wooden lifeboats were loaded, barely enough for half on board.
Inside, carpenters fitted intricate oak paneling, hiding the cold steel frame. Plumbers installed complex piping for the luxurious, heat-controlled Turkish baths.
The framework for the grand staircase rose, the future centerpiece of first class.
An ornate glass dome was lowered, flooding the staircase with natural light. A dining saloon was fitted, capable of seating over 500 guests. Massive stoves were installed to feed thousands of hungry passengers.
Staterooms received plush carpets and beds, rivaling the finest hotels in Europe.
Below, simple steel bunks were bolted in for third-class passengers.
Tons of coal were loaded, the black fuel that would drive the engines.
Furnaces were lit for the first time, building the immense steam pressure.
Smoke rose from the funnels. The sleeping giant had awakened.
April 2nd, 1912. The Titanic moved under her own power for sea trials.
Engineers tested the rudder, executing a full turning circle in the Irish Sea.
With trials complete, Harland and Wolff signed the vessel over to White Star.
The finished Titanic departed Belfast for Southampton to begin her maiden voyage.
A triumph of engineering. She was the largest, most luxurious